So in this problem, we have a boat going downstream at a certain rate. Obviously, when it comes back upstream, even though it's the same distance, it's going to take longer because the rate of the water working against the boat is going to slow it down. So they want us to find the speed of the boat in still water, which means what if there were no current at all? How fast would the boat be going? All right. Something you're going to want to remember in this problem is that distance equals rate times time. So the distance is given to us. It's 336 miles. And the times are given to us in each situation, 12 and 14 hours. The tricky part is the rate. The rate comes from two things here. The rate comes from how fast the boat's motor is propelling it, and then also how fast the current of the water is. And those are really our two unknowns here. If you let B equal, I'll say speed of the boat by itself, and then W equal the speed of the water, whatever you want to call it. You call it C for current. Again, you wouldn't want to just say B equals boat and W equals water. That does not include like a label or a concept. It could be a number of boats or a number of water. It doesn't make sense to the reader. So be clear specifically what you're defining your variables to be. That's why that section is on every problem on the worksheet. So the two equations you're going to want to write come from the idea of distance equaling rate times time. So when we go downstream, the distance is 336, and the rate is with the boat and the water helping each other out. So what we really have here is the boat's speed plus the water speed pushing it along. That's going to be B plus W is going to be faster than just plain old B, which makes a little bit of sense here because we're going downstream. We should be going faster than if we were going upstream or without any current at all. So B plus W is going to be the overall rate, the boat's rate plus the water's rate working together. Times time, in this case, is 12. And then when you go upstream, you still have to go 336 miles. You still have the boat's speed as a main factor here, but now instead of the W helping the boat's speed, the W is going to be working against the boat's speed, meaning you can take the boat's speed and subtract the water's speed because it is fighting against that speed of the boat. And the time for this would be 14. So we have distance equals rate times time for both of these situations, and that's what forms our system of equations here. To solve the system, I'm thinking we probably want to distribute the 12 through and the 14 through. So I'm going to rewrite these equations as 336 equals 12B plus 12W, and then 336 equals 14B minus 14W. We can do elimination on this system. I'm probably going to want to eliminate the W's because they at least already have a plus and a minus lined up with each other. I won't have to mess around with multiplying stuff by negative numbers. So we just need to get a number that 12 and 14 will agree on. We could multiply the top by 14 and the bottom by 12. I think it would work to cut those both in half. So if you multiply the top by 7 and the bottom by 6, I think they'll both make 84 and negative 84. So I'm going to multiply the top by 7. I'm going to multiply the bottom by 6. Might need a calculator on this one. But 336 times 7 would give you 2352. 12 times 7 will give you 84. And 12 times 7 will give you 84 again. Underneath, 336 times 6, I'm literally typing this into a calculator as we talk. 2016, 14 times 6 would be, wait a minute. Yeah, 84 and 84W. So if we add down the columns, 2352 plus 2016 let's see, 43/68. This would be 168B, and the W's will get eliminated. So now you can tell that B is going to be, so you divide 43/68 by 168, and you get 26. Now, frankly, we don't even need to know what W is. All it's asking us in this problem is, what is the speed of the... Oh, wait, never mind. It does ask us for both. What's the speed of the boat in still water? Well, that's 26 miles per hour. We've already defined B to be the speed of the boat. And then also, what's the speed of the current, or the water? Well, if you plug 26 in for B in any of these equations, I'll go up here. You get 336 equals 12 times 26 plus 12 times W. 12 times 26 is 312. So 336 is 312 plus 12W. Take away the 312, you get 24 is 12W. So W must be 2 miles per hour. And you've answered the whole question.